All right, thank you, everyone. Can we actually grab a second mic by chance?
No, impossible. Okay. We do the impossible 3 times.
3 times over.
Before breakfast.
All right, welcome, everyone. This is Back to the Future, Owning Systems of the Past. Briefly, I'm Nick Gregory at KL Sims, basically everywhere.
And I'm Dolan-Gavitt, and tonight we're going back to the future.
Professionally, we do AI and a bunch more stuff at Expo. This is very tangentially related, but yeah, anyways. So, brief overview of what we're going to be talking about. Basically, 4 steps. Reverse engineering, where's the bug? Emulator, how do we actually run all of these old things? How do we actually set up the environment so we can debug all of these exploits, which of course aren't going to work the first time, even as insecure as these things are. And then how do we validate that these AI agents that we have going off and doing all of these things have actually done what we asked them and aren't just, you know, SSHing in, running calc, and then being like, look, a calculator has like appeared. That's crazy. One thing I do want to get out of the way up front too, this is just using stock codecs with GPT 5.4, 5.5, and 5.6. You can do this at home too. These agents are now staying coherent for like hours to days. So a lot of what we're talking about isn't really the exploit side directly. It's how do you set these things up in a way that, you know, priming the correct initial conditions for them to then just press go and go off for a while and, you know, hopefully come back with some calculator spawned.
Yeah, so these are more organically grown rather than artificially created exploits. So there's all sorts of exciting roadblocks once you start trying to exhume systems from 20, 30 years ago. One of the more annoying ones is that many times the companies won't actually legally sell you the software anymore, and so you have to get maybe a little bit creative. So with perhaps a little bit of copyright, say, sidestepping, we got our AI to make us some keygens. And of course, once we made it, we said, oh, no, you need more glowing things, more cyan, and some MIDI. So this is one of the worst chiptunes I've ever heard. But that is authentically GPT 5.5's own creation. So, okay. So yeah, you know, we were going to try to just cover a broad swath of browsers and operating systems, but one question is like, okay, like what's actually in scope here? So we set the ground rules as for the browser exploits, you got to be able to just go to a malicious website. Sometimes we try to go to like file://bin/sh, not allowed. And so for the network attack surfaces, we want to go with default enabled services on classic Unix systems. It turns out this is not actually a limiting factor because, my God, they enable a ton of network services.
It's fantastic.
But what this does rule out is, unfortunately, if you're hoping to see us hack a Cray, that's not going to happen because those are not usually on the public internet. On the other hand, if you need to protect against Velociraptor attacks, that we can help you with.
It's a Unix system. We know this. So starting off with reverse engineering side, there's kind of 2 approaches that we ended up taking. There's what you might expect of use the AI native way of an MCP server and point it at Ghidra and say, go forth and hack my child. But we also found that actually just getting a kind of complete pre-decompilation out of Ghidra and then pointing the agents at here's a file structure, you know, like it would just be examining a repository, is also quite effective. Strangely enough, somewhere in this, GPT ended up thinking that Netscape was still a production browser. Not entirely sure how it got there, but as well as to show it's not entirely wrong in some ways, which is always great fun. But anyway, so we're giving 16 whatever it is different kind of entire operating systems or browser or both to look at across, I think, a decade and a half, roughly. And so one of the issues that we have to deal with here is there might not be a Ghidra loader for this file format, or the CPU definition for, was it alpha, maybe?
Yeah, it's pretty incomplete.
Yeah, it was very incomplete to Ghidra, so the decompilation was not very good. But one quote that Brendan gave while we were preparing for this was, AIs are great because you can yak shave faster than ever before.
I've shaved so many yaks.
So
It's
many
great.
yaks. It's amazing. Right, because we're doing effectively blind reverse engineering of most of an OS's or 5 TCP/IP stacks, 7, 8 different browsers or something like that. Again, maybe partially source available, but from either way before or way after. And so there's a lot of RE involved here. It's not just, haha, there's bug. One other thing I do want to actually point out, with pre-decompilation, what's really nice with that is you can just let sub-agents go wild. So you can, get a real idea of where some bugs are across this large scope of, this large swath of code in like 10 minutes. So pretty neat.
Yeah. So getting back to this question of how the hell do you actually run these things? So it turns out, I'm not going to try and actually go and collect a giant, set of, vac stations and things like that in my shoebox New York apartment, because I would be murdered. But what we can do is say, let's try to emulate all of these in QEMU. So you can fork QEMU as many times as you want. It's free. I have 20 QEMU forks sitting on my hard drive now. But you run into really weird things, like the fact that on the alpha, because they wanted to support VMS, they support 2 different floating point modes. Standard IEEE, that we know and love, but then also a VAX floating point mode that turns out the browser's libpng used to do calculations. And so if you don't implement VAX floating point, you get browser crashes that have nothing to do with your exploits, and that will not do. So we also wanted to standardize on QEMU because otherwise, if you try to use some of these more homegrown emulators, you're not going to get nice things like snapshots. They're going to be crazy slow. And unfortunately, agents have no sense of time. And so they do not know how excruciating it is to watch them try to do one shot at an exploit every 30 minutes while they wait for the thing to boot.
Yep.
So the nice thing, though, is that, again, you can really make them do terrible things that you would not ask a human to do. So, for example, to get a True64 exploit working, I made it install 7 different versions of True64 from scratch because there was one that had the right uninitialized stack contents that let this program run in the first place. So you can do that kind of thing. The other kinds of things that you need to avoid them doing is trying to use things like VNC to control things. It doesn't really work well. They aren't good at it. And also making sure that they don't step on their own feet while they're trying to debug things. They really like to try to debug things as if they're normal programs, but when you're doing heap exploitation, that's not the right way to go.
And one other kind of personal anecdote with this, I think I had to reinstall Windows 98 3 times before I got the right driver incantation for modern QEMU, and it wouldn't blue screen back to back to back. So
that was basically my childhood, though, so it's not that bad.
And lastly, kind of before we dive into a bit more, validation. How do we know that these agents actually did what we asked? There's, again, kind of a conventional route of use flags like we have for CTFs for many years. They're very in distribution for what the models are supposed to do, and even without kind of this wrapper of /goal to kind of prod the model along to do something, you can get things running for days. I think 3 or 4 days just out of the box saying get the flag. There's also screenshots though. You can just say did calc open, and this is also pretty effective once you get enough of hey, don't do that slap on wrist. You don't have to make it foolproof from the start. You can kind of correct it along the way. And generally, the agents now, once you tell them, hey, don't do that, they won't do it anymore.
They'll cheat in a different way.
They'll cheat in a different way. They will monkey paw you over and over and over, but not that way. They love to use GDB to attach to QEMU and be like, oh, wow, I found the flag in the memory. It's crazy. Who would have put that there? So /goal, what do these models actually end up doing now that we've kind of set up what we're giving them to work in? Well, sort of Brendan sort of alluded to, they love to test things in like a modern fashion, which doesn't really work. So, oh, there's this really interesting, heap use after free. I can use like some of the heap feng shui tech. No, you can't. No, you can't. This is not the glibc you're familiar with. Additionally, a lot of stuff is just wildly out of distribution to start with, right? Register windows aren't really a thing anymore for basically any architecture that it will have seen much use of in its training. Additionally, one thing I ran into that was fun was for macOS 9, it needed to figure out how to do 68K in the emulator that macOS 9 has so that 68K runs on PowerPC natively. And so figuring out that it needed to do that, and then like how to bridge between the two worlds was interesting. And then, of course, like we said, the models will still monkey paw you. They will still try and find ways to weasel out of hard problems, like having to RE a custom heap implementation, or sometimes they would just be like, wow, I can just patch the binary, and again, like a flag has wildly appeared. And that's, no.
Yeah, and so, the other kinds of things where they really just fall on their face is they are willing to go and pursue a hypothesis without sometimes checking maybe whether that is actually a reasonable thing. So poor GPT-5.4 spent about 12 hours working on an amazing exploit for like a really cool bug that it thought it had found that once it got slightly better instrumentation, discovered was a null pointer dereference. So not super exploitable. The other kinds of things are they are wildly overconfident in abilities that they don't necessarily have. So for example, when I was trying to get the emulated graphics stack up and running on alpha, it would do things like say, here you go, got the graphics stat working. Looks good, right, mate?
Ship it.
Yep. Yeah, no, looks good to me. So this is the kind of thing that you have to actually, unfortunately, still have some human eyeballs in the loop, or give it some tools for saying, like, look, just count the number of freaking blue pixels on the screen. Like, if it's more than 90%, you have not succeeded yet. And then, of course, we mentioned some cheating. They love doing things like writing exploits where it's like, oh, I just need one address. So I will pause the exploit here, SSH into the box, read it out of procmem, and then go back to the exploit. Do not see a contradiction here. So I'm not going to go and read all these targets. This is like what I consider the greatest hits of browsers over the past 20 years here. And then, of course, if you want something that's a little more wormable, a little bit less client-side, you can also go after network services and core TCP/IP stacks. And then finally, if you're feeling just like really freaky, you can try to exploit an emulated Lisp machine running on an emulated alpha running True64 on your modern laptop. But okay, now that you've suffered through us talking about agentic-driven development, I know what you really want is to see a lot of videos of calculators popping up on screen. So let's get started. So this is Mosaic 2.4, running on OpenVMS on a VAX emulator. You can see that we can get calculator pretty quickly. How did it do that? Well, it turns out that Mosaic supports an image file format that you may have never heard of called XPM. And that by overflowing this with exactly 8,229 bytes, not one more, not one less, you can then take control of the parser and get it to overwrite the equivalent of the PLT on this VAX, which is DEXC dollar system, at which point you can now jump into the pixel data and run your exploit. So, of course, this is a very serious vulnerability. As everyone knows, if you're a hardcore anti-vaxxer, this was the exploit for you. Yeah. Okay. But so maybe for some browsers you might have actually used in the past. So this is Netscape Navigator. I really like this one because as part of the exploit, which was basically a mistake in how it handled the select and option tags, it was able to end up overwriting system. But the function pointer that it overwrote was stirred up. And stirred up is called a lot, which is why when you try to run system, you suddenly start running system on a bunch of HTTP headers along with your calculator. So this is not what I would call a clean, weaponized, production-grade exploit, but it looks really funny.
We still got calc.
Doesn't matter, it got calc. So we can also go forward. This is Netscape 5. They never actually released this one, but they actually did release the source. So you can, this is actually a slightly easier variant of it. And it lets you, again, pop calc.
Oh.
Right. So Dino, who may be in the audience, so we're going to show his tweets and embarrass him, does mention that this does occasionally have very nice, maybe practical effects, which are if you're on a pen test engagement and the customer says, no, accepted risk, no one would ever write an exploit for Netscape. Now you can come back and say, oh, well, these guys did.
All right, so moving on. This is Solaris 2.6 on Spark with a lovely IE5. Gotta love Gopher doing its best at being a protocol which can be used to exploit things. Let's get there we go. There's calc. Basically, it's a pretty simple one. Just shift a pointer with inside of a fixed stack buffer. You can then end up using a subsequent write to kind of blow past the end of the allocated size. Spark's interesting because of register windows. So you don't end up just like overwriting a return pointer. You end up actually overwriting like a whole series of registers, and then those get pulled off. There's a little bit of magic that happens with, again, what we're overwriting is actually something that's then later used as a pointer. So it's not even directly a direct PC control. It manipulates some registers which then have like second order effects down the line. It's definitely interesting to see, again, that you can still reason through these. And you might notice that little icon next to the end of the title. This is one where we actually got a double kill. So there's another one in IE5 where array.sort ends up doing some 32-bit math on a length field. You can probably see where this is going. Big number times 4 or so happens to suddenly become not so big number. And so you can end up just doing a pretty easy, just out of bounds write with that. There's, again, a bit more shenanigans that have to go around with how the second half of the exploit, but we only have so much time. So the compact secure web browser, one that you may not have heard much about. However, you remember when I was saying before that Netscape isn't a production browser? So the bug that it actually exploits here in binhex parsing code. Oh, did it not start automatically? Yeah, the bug that actually starts exploiting here is the 1 byte out of bounds read, which lets you control the low byte of an adjacent pointer. This survived until 2017. So it's maybe the models weren't quite so wrong that it's actually still kind of production.
Yeah.
Running on alpha, there's a bit of interesting stuff here where it's, again, not just your normal like i386 overflow the stack, hit a return pointer, and ta-da. You get some fun with having to use OpenVMS's DCL commands, which are sort of analogous to like binsh in a way. So you end up having to just run this really weird esoteric string, and it ends up working similar to how you might expect, though, at the end of the day. Yeah, and then there's the actual CV for this bug, about 15 years later, call it.
Yeah. Okay. And so then, of course, it's not all fun and games. Some of it is just games. So on this one, we had the Dreamcast, which actually had a broadband adapter and a web browser. And I was like, well, you know what? If it had a web browser, it's in scope. We're going to exploit it.
Oh, yeah.
And the other thing that I liked about this is that it's very much kind of its times. So this loads a macromedia Flash applet and then redirects from the Flash applet into an overflow in port parsing, which then turns into a normal kind of stack-based buffer overflow. But the fun thing is that since this is a game console, you can ask GPT, like, give me a real cool, like, post-exploitation splash screen, and it'll come up with this insane vaporwave thing.
Yeah. Give me the aesthetic GPT.
This was the point where people started asking if I was still employed, and
It's a valid question,
Yeah,
right?
yeah. and the answer is I won't be once they see the token bill. Okay, let's get back to more of the stylish, classy ones. So this is net positive running on BOS. BOS was amazing because you could do things like show a GL accelerated teapot. And because of the magic of modern AI, you can now show a GL accelerated teapot by parsing attacker-controlled data coming back from an FTP server. Meanwhile, we've got things like NextStep, historically very important operating system because that's where the web was born, and that's where the web got exploited here. So, in fact, on this one, we actually ended up exploiting TalkD. So this was a weird sort of exploit, and maybe this starts to stretch the bounds of historical accuracy because the way that this exploit worked is it was actually an overflow in the reverse DNS lookup when you connect via IP. So if you were an attacker that controlled your own IP address range, you could make repeated connections from different IPs, control the reverse DNS resolution, and use that to overflow the the hostname parsing, and stage your exploit into memory. So this particular exploit ends up basically creating its own new user, and then logging in as that user to run the 3D chess program that came with NextStep.
One thing I want to point out here too, in particular, since you can't actually run stuff directly from like the daemon context that this used, the exploit ends up effectively emulating keystrokes to launch this. So, yet another fun way to exploit things. So next up, we have a nice classic, macOS 9.2.1. May it rest in peace. This is kind of one of two that are particularly interesting because it's almost the exact same bug across two different operating systems with completely independent network parsing code. There's some extension to IPv4, which is not very commonly used, but is apparently very buggy to implement, which lets you do a pretty classic, I am giving you something of length 4 and then give it length like 100, and it just, length is used to allocate and data is blindly copied in, for example. The kind of post-exploit chain is a little bit interesting here because, well, this isn't a preemptive operating system. So this also made the exploit kind of retry chain particularly annoying because, well, you take down the entire system, or in some cases you don't because your exploit like hangs or like gets into an infinite loop and then nothing ever comes back. This was a particularly fun note under my post for this. Sad to say, I completely believe it. Yeah. And then we've got another venerable target, Windows 98 SE. Again, exact same extension to IPv4. Pointer beyond declared length. This is a little bit interesting because it's not actually a clean write. It ends up swapping pointers, so you end up actually doing this, changing one, and then basically doing the same thing again to swap it back to where you actually need it. And again, more Windows NT internal nonsense and not actually having proper kernel isolation for these drivers. Moving on, because we're running low on time.
Yeah. So this is an IRIC system. So these were SGI rendering machines. I almost didn't believe how stupid this vulnerability was because it turns out that there is a pre-auth vulnerability in one of the line drawing daemons where you can literally just specify a callback and arguments and then disconnect and it will run your callback. So this is almost not a vulnerability, like it's just really stupid design. And this starts to become kind of a recurring theme. So moving on to True64, we got a couple ones here. They were both in the ToolTalk database. And the main reason I ended up doing these is because I mentioned that I was using True64, and Dave Attell was like, oh, if you're using True64, why aren't you exploiting ToolTalk database? And so I said, fine, I'll go exploit ToolTalk database. Okay. All right. And so this is kind of where we hit the end of the road. So I was like, okay, look, a Lisp machine, that's a weird thing. Can we exploit that? It's hard to actually get a real Lisp machine. I tried. And so we ended up running on an emulated Lisp machine. And the problem here is that at this point, things get almost too easy. So this vulnerability is that when you connect to an FTP server, it sends back the current directory, and the Lisp interpreter runs eval on it, because that's what you do in Lisp. So there's not really, again, like, this is super easy to exploit, right? You just send some Lisp code in your PWD, right?
So, are these production-grade exploits? No, right? They're currently pretty fragile. They do work, right, as you've seen, but they rely on some constants, which probably don't vary from boot to boot, but maybe do. There's some assumptions about layout and memory. You know, even though we are restarting machines, QEMU is pretty deterministic, it turns out. And so as sort of a case study of this, we had 3 RC class network reachable bugs in macOS 9.2.2. We had an additional bug in the port of Netscape 4.7 to 9.2.2. And GPT-5 could not make it work reliably, no matter how much we tried our damnedest to prompt it. So we're going to try this. It probably won't work,
yeah,
but we're going to give it a shot.
Yeah, and we're not saying this just to build suspense. We really made the decision that here, like, it was better to die on your feet than live on your knees.
Yep.
So let's do this. So I'm going to open up Netscape Navigator. So you can all see it, or Netscape Communicator. Yes. Very nice. Okay. So, yeah, this is getting lots of Blair Witch vibes here, but... all right, can we see this? Yeah, we can see this. Okay, http://10.12. Yep, okay, it's got that. calc.html. And let's see if this works. So one thing that's kind of fun here is it's trying to leak addresses into the select box there. So okay, that one missed. So ready, aim, fire. No, that's a miss. All right, we're going to give it one more. No, come on, keep going, keep going.
One of these
No
days.
Emmys, no Emmys.
No, no.
Okay, well, all right. And we've killed the browser. But, all right, so this is all to say, if you are a nation state, probably don't let your LLMs write the exploits entirely on their own just yet.
Unfortunately. So some closing words. Are these targets hard? Right? Not really. This is before memory safety was like a thing that should even really be considered as the should do. Right, we had a case in particular where we were just trying to put a file on the machine and accidentally just like completely froze it because, oops, we put too much data into your buffer, sorry. But also, like, the bugs are still real at the end of the day. And, you know, like I said, one of these was only actually CV'd 9 years ago instead of 25. So there's some interesting stuff to be had. And then, of course, as one last thing, anyone want some exploits? We have some thumb drives, perfectly labeled. I promise it won't own anything that you're actually running right now.
Yeah. So thanks, everyone, for listening. And if you got any questions, we can do our best. All right. Oh, there we go. One in there.
Yeah.
So Netscape turned out to be the dividing line. So Netscape was too new and too production grade to exploit straight up. So we had to frame that one as a retro CTF challenge.
Yeah. Can you repeat the question originally?
Oh yeah, sorry. So the original question there was, do we have to convince GPT to exploit things, or was it willing to say like, oh, this is old enough that it's not production anymore?
Yeah.
How many CVEs have you got to sign for this work?
-1,000. we took your CVEs. No. Yeah, so we could try to send some of these OS 9 bugs to Apple if we want to get some laughs out of them.
What else? We got another.
Sorry, do any steering for the? Yeah, right here.
Did we have to do any steering for the talk D exploit? Is what I heard. Is that?
Okay. So that
for it.
one wasn't. So yeah, do we have to do any steering for the TalkD exploit? So that one wasn't too much. The main thing with that one was telling it that it was allowed to use bridge networking so that it could get the reverse DNS.
Yeah. And then I think we got one more. How much did the whole thing cost? For legal reasons.
Yeah. Not enough to get me fired yet.
Yeah. I can tell you my part was just done on a subscription that I pay for, so only $200 or whatever the pro subscription is. But anyways, alrighty. I think that's it. Thank you, everyone.